Now let's refer to example 3 for sketching the graph of cubic functions. Now we have the case that the functions can also be completely factorized, but this time it happens to have a repeating linear factors. So the techniques here is similar like what we have on the example number 2. So step 1, we identify the type. In this case here, the type that we're referring is that it can be completely factorized with one of the linear factors is happen to be repeating linear factors. And in here, there's a remark important to take notes. For the parts that we have repeating linear factors, it is actually the extremum point that located on the x-axis. And how shall it located? We'll see later after we happen to identify the shape of the graph and also the x-intercept. Step 2 now, the shape of the graph. So in this case here, by the time we expand the x term accordingly, so we find out that we have the coefficient for the x cube is a positive value. So the shape of the graph will be in this form here, from sad to happy. So this is the shape of the graph where we have maximum, minimum point. And next, the special point again is the maximum and also minimum point. However, the way to do the calculation to find out the maximum and minimum point is not so emphasized in this case here. However, if you want to know how to get the answer, you may just by using differentiation to get the answer. Next, we go on with the calculation for the xy intercept. In this case here, once again, since we notice that it can completely factorize, for sure it will have x-intercept, and so do the y-intercept. Next, so since we know the x and y-intercept exist, we just proceed with the calculation where we find out that the y-intercept, when x equals to 0, we have fx equals to -3, so the y-intercept is -3. Whereas for the x-intercept, when the time the fx equals to 0, we have the value x equals to 1/2 and also 3. So the x-intercept is at 1/2 and 3. And be aware in here one thing, you find out that the value of 1/2 and 3 is actually obtained by referring to these brackets here, equals to 0. For the case of 1 minus 2x equals to 0, we have x equals to 1/2, and this x here is occur at the part that we have linear factor power of 2. And based on the remark just now, by right, this corresponding x value here will be an extremum point in our graph sketching later. Okay, and how does it will happens to form? Let us see the graph here. So similar like just now, we plot out the x and y intercept out first, and just now we notice that we have the x-intercept at x equals to 1/2. It's actually an extremum point. And how does the extremum point will happen to be formed? So let us see. The shape of our graph will happens to located in this form here. Will happens to be in this form here. And we notice that at the point of x equals to 1/2, it should be the extremum point. So when the time we try to put in our graph inside, so it can happen in the way that I have the extremum point located in this way, or I can have the extremum point located in the other way. So let's say call it case 1, case 2. And let us see which one is supposed to be more make sense, where both of these points here is actually the x-intercept, and according to the calculation for x-intercept, we find out is that 1/2 and also 3. So 1/2, 3, 1/2, 3. And we notice that 1/2 must be an extremum point, therefore the shape of the graph should be the case 1, not the case 2. Because once again, x equals to 1 over 2 is contribute from the linear factors that have square. And as a result now, this is the shape of the graph that I should have. And before we end the presentations here, so once again, remember, in your graph, make sure you do label the xy axis, label the origin, label the name of the graph, function f, the x and y intercept, and suppose I should need to label the maximum and minimum point. However, once again, the calculations by using differentiation is not introduced yet so far until chapter 5. That's why I just leave the graph in this form here. So after we have go through chapter 9, differentiations, maybe we can complete label the maximum and minimum point. So therefore, this is the answer for example 3 in sketching cubic functions.